In this video, we're going to talk about generics, and these are very much related to the array list that we covered in the previous video. The reason that is because an array list is a type of generic. So you'll also see the terminology for generics interchanged with parameterized class, or a generic definition, and sometimes you might also see a type interface. But we usually take the approach of just calling it a generic. All right, so these are all just different terms for the same thing and will help us with what we're doing moving forward. So we're just going to call it a generic. And this starts on page 782 of your textbook. So we're just going to go over some of the things that are involved in this. And we're going to go over a simple example here of how we might define one. Now, the purpose behind this is basically what we did with the array list. Now, with the array list, we used an example of a string as the base type throughout. But what if we wanted to use a different type? Well, we would just replace the word string with whatever type of object we wanted to put in there, right? We would do something like array list. And if we wanted to use an integer wrapper class, we would just put integer into those brackets, and there we go. We have a definition of an integer array list, and we're going to get all the same methods that we would get if it was the string array list. They're all going to behave the same way. It's a data structure where we change the type of data stored. Okay, so that should be pretty simple to understand, but the hard part is writing our own. Right? We have a public class, and then we're going to say a type here, T. Now it's important that we make sure, actually, I messed up a little bit. We're going to public class, and then the name of our class. So in this example here, I'm going to do a class called, if I cannot hit that erase button for once, my class. And then we do those little less than or equal to, less than or greater than brackets, and then we're going to do a T inside of that. Now, it doesn't have to be a T. A T is just an example. We can put anything we want there, any singular word or letter. All right, and then we're going to store, let's say that we wanted to create an ordered pair class, right? We would store that data in something like a private variable. Basically, anywhere we wanted to use that type, we would reference it in this way. So we'd say private T, and then data, the data that we wanted to store. All right. And anywhere we reuse this T, so if I'm going to change the color here, we're going to change that to a nice bright blue. And this blue here. This is going to replace it with the type of data that we put in. So if I did something like, I don't know, let's say we had a new my class, we would instantiate it in the same way that we did that array list. So let's say we wanted to put a string in here, we could do that. Put string, and then we would put our variable name, so my object. All right, so anywhere we put in this string type, it is going to be inserted wherever we put that T before. Now do remember the T is only an example. It works very similarly to a variable name. It's reserving that value, that type in this case, for use throughout the program. All right, we can also use it for method signatures. So if we wanted to use a method signature, we would do something like, let's say it's a public, and we wanted to return type T, and let's just call it my method. right? And we'd have some code in here. It doesn't really matter what it is, but we'd have some code in there. And that t is again going to get replaced with our type that we put into our definition. And this is really useful because it allows us to do a lot of things. It allows us to create these generic classes that can take different data types, which is really useful when you're trying to wrap data into an object that behaves in a particular way. You're not necessarily caring so much about the type of data that's put into there. You're more worried about the way that data interacts in this kind of overall data structure. So if you're writing your own structures, like from your algorithms course or from a previous course that you've had in computer science, right? Let's say you had to write your own hash map class. This is how you could do it without worrying about whether or not it's an integer or if it's a string or some other type of data. Now, we can also do multiple types, and we would just do this in a very similar way. We would do something like public class, and we're just going to say my class again. So this is a new definition, but instead of doing that t, we can do t1 and we can do t2. All right, so now we have a class that uses multiple different types. And when we go to instantiate it, we will do that by doing something like very similar to what we did before, where we do my class. And instead of just having one type inside of these brackets here, we are going to have two types. We're going to have a string and we're going to have an integer. And that's going to give us what we want out of this multiple types here. Okay, so that's the general idea about generics. Now you can bound this type. So let's say we wanted t to be a type that had implemented some particular interface, right? We can actually do that. We would say something, if that's what we wanted, we'd say public class my class, right? And we would say, right, we'd say, need that blue color back, t, and we'd use that appropriate keyword here. So let's say it's extending another class. So extends, and then let's say we had, my parent class here, because I don't know what we're extending from. This is just an example. My parent. All right. This makes sure that any t that we put into this has to have that parent. All right. It has to extend that particular class. Now, we could also use like an implements here so that it implements a particular interface. There's a lot of things that we can do to make this more useful. And a good example of this is actually on page, we've got 785 for the ordered pairs, which is a really good use of it. And we also have an example on, looking for another example in here, on page 791 for using multiple types. So again, that is pages. I said 791 for multiple types. We had page 787, or sorry, not 787, page 785, 791. 785 was one type, one generic type. 791 is an example of having multiple types. All right, and then we have the example on 795 for what I was just talking about with having it bounded by a particular type. So a good example of this is actually the extends. We could do a comparable in here. So if we take away my parent, we could say it has to extends comparable. All right, so that's something that's really useful because we can make sure we have certain properties on our type so that we can use it in particular ways. We can expect certain methods from that interface that we expect it to have and to use. All right, now some other things that you can do is you can have a static method. So if we have a generic method with public static, this means that we basically define it in a little bit of a different way. And I'm not really going to go over that because this is about as much as you're going to really need to know. There's more details on this on page 796. Okay, so these are the important pages here for what you should cover for what I'm kind of glossing over a little bit. But on page 796, we talk a little bit about how to do methods with generics. So I talked about that just a little bit. My example isn't quite 100% correct, but is just a kind of a brief example of what that might look like. And I will reorganize this whiteboard after I'm done making this video just to make it a little bit clear what I'm talking about. I kind of did a lot of writing on here that I didn't expect to be doing. So I'll reorganize this to make it a little bit clearer. All right, so that's the idea behind generics. And remember that the array list is an example of a generic that's included in Java by default. And in order to use it, you just have to import it. We can make our own things that are like that by defining it with this syntax. All right, again, if you have any questions, make sure you're messaging me on Teams. Make sure you're sending me those questions so I can answer them. I've gotten a few questions recently, and we're going to be hitting more complicated materials, so it's really important that you understand what's happening here. And if you're not understanding it, make sure you send me that question. If a lot of people have the same question, I'll make new videos to talk about the things that I glossed over or I missed, or maybe I was a little bit confusing about. So if you don't send me those questions, I can't do that. So let me know if I didn't cover anything, if I didn't cover something in enough depth, whether it's from this week or a previous week.